All right, we've factored quadratics, we've graphed quadratics. Now it's time to solve quadratics. Okay, so I've got this written here, and it's kind of not the best place for me to write it because it doesn't pertain to this part over here. Okay, but if I'm going to solve by graphing and if I'm going to solve by factoring, I need to first set it equal to 0. All right, so that's a big deal, especially down here when we're talking about factoring. Okay, and again, that wasn't the best place to write it, but I wasn't thinking clearly. All right, the other thing is that you have to think of 4 words that mean the same thing, and that's going to help you a lot. And it's not just right now in Math 1, but it's going to continue. So you have 4 words. Okay, we got solution, root, 0, and X-Intercept. All 4 of those mean the same thing. And that's important because sometimes it throws you off and they'll say, what are the roots of this function? Well, then you think, oh, that's just the solution, or that's just the X-intercept, okay? So don't let root and 0 throw you off. These all mean the same thing. But what that also means is that if you're solving, if you're looking for a solution, one option is always going to be to find the X-intercept. So for the first example, I'm solving by graphing, and to solve by graphing, I look for the X-intercepts. So this is a quadratic because it's a parabola, and I have 2 X-intercepts. That means I have 2 solutions. So I know that X equals -1 and +3. So my solutions are -1 and 3. Just that easy when it comes down to solving by graphing. Just graph it, see where your X-intercepts are. All right. Then we have the algebraic side of solving quadratics, right? I'm solving and I want to get down to what x equals. So one option is if I only have x squareds. So I don't have any other x's in there except for x squared. So I have one x. I can get that by itself by doing my inverse operations, right? Well, the opposite of squaring is square rooting. Right? So if I wanted to get x by itself, I could do that by taking a square root of both sides. That's going to get down to x equals, and then the square root of 16 is 4. Almost. You got to remember, we kind of talked about it when we were plugging back in one of our previous videos. If I square 4, I get 16. But there's another number that if I square, I get 16. And that's going to be a -4. Remember, a negative square, it's going to be a positive. All right, so that means that when we write my answer here, I have to take into account the 4 and the -4. So one way of writing it is to put what we call plus or minus in front. So x equals plus or minus 4. That means positive and -4. Or you can write it out and say that your answers are 4, -4. All right, but that's what the plus or minus means, that you have a positive and a negative. So when we do our square roots, you always have to take into account the positive and the negative when we're dealing with solving quadratics. All right, now for the second one, don't take the square root yet. Wait until you get down to the x by itself. So I'm going to start by dividing by 2, moving that 2 over. Then I'm going to have x squared equals 4. Now it's a lot easier when I take the square root of both sides, because 4 is a perfect square. So I can say x equals plus or minus, don't forget the plus or minus, 2. All right. Then for the last one, I can't move the 3 yet, because remember, if we go back to our order of operations, we talked about way in the beginning with solving equations. When I solve, I got to do the opposite of order of operations, right? So before I do the parentheses, I have to do the exponents. Okay, so you can't break apart the parentheses in here until there's no exponents on the outside. So that means to get rid of the square, I'm going to go ahead and square root now. So that I'm left with just x plus 3 over here because I got rid of the squared. And then the square root of 25 is plus or minus 5. So this one looks a little weird. I'm going to subtract 3 from both sides to get x by itself. But now I have a positive and a -5 over here. I have to subtract 3 from both of them. All right, so that means I'm going to have to do, let's do 5 minus 3 and -5 minus 3 because I have both plus or minus 5. So 5 minus 3 is 2. So there's one of my answers. And then -5 minus 3 is -8. So my answers are 2 and -8. The biggest thing here is make sure you take both positive and negative. That's like a huge part that everybody misses. That's like very common for people to forget the plus or the minus. Okay, because also with a quadratic, you can have 2 x-intercepts, right? Or like in the one we saw when we were graphing, we had one where the x-intercept was on the x-axis and it went up, so you only have 1 x-intercept. Okay, or you could have a u all the way above it where it never crosses. So that means you can have 2 solutions, 1 solution, or no solution. Okay. All right, solving by factoring goes back to factor. This is where it's most important, where I should have written this. This is where we need to set it equal to 0. This is the big key here. All right, so before you factor, set it equal to 0. Then you're always going to look for GCF first. Right? Then if you have the pattern difference of squares, or you'll have a plain Jane trinomial, or you'll use bottoms up. So it just depends on the scenario when we're doing these. So the first one we're working with here is a plain Jane trinomial. So I go straight to parentheses. Okay? I want to multiply to -8, but add to a +2. So that's going to be a +4 and a -2. Now remember, this is an equation. I've got an equal sign here. All right, when I go to solve by factoring, we use what we call the zero product property. All right, that means that if I have this parentheses times this parentheses and I want to equal 0, at least one of them has to be 0. Right, that's the only way I can multiply to get 0. Like 5 times 0 is 0. So our zero product property says that I can take each one of these and set them equal to 0, because that means if this one equals 0, I have a true statement, and if this one equals 0, I have a true statement. All right, then to solve, I can subtract 4 from both sides, so I get one option is that x equals 4, and then I can add 2 to both sides, so my other option is that x equals 2. So my answers are -4 and 2. Right, now that was a lot of talking, but the biggest thing is when you solve by factoring, you factor, and then take everything and set it equal to 0, so that you can figure out what x is. For number 2, I've got to set it equal to 0 before I can start factoring, right? Because that's what's going to get us to that zero product property. So the first thing I'm going to do is add 1, move it over. So I got x squared plus 2x plus 1 equals 0. Okay, plain Jane trinomial. I want to multiply to 1, but add to 2. So it's going to be plus 1 plus 1. Okay, equals 0, and then I can take these and set them equal to 0. Right, so subtract the 1 over, subtract the 1 over, so I get x equals -1 and x equals -1, but those are the same. That means that this particular quadratic only has one solution. You don't have to write it twice, like my answer would just be x equals -1. Right, now if you also notice, if I do the plain Jane trinomial and I just have x plus or minus a number, my answer ends up being the opposite sign. Because anytime we have something inside parentheses and we're taking it out, we use the opposite sign. So you don't have to write all this stuff in between. If I get down to an x plus 1, my answer is going to be an opposite, -1. If I have an x plus 5, my answer is going to be a -5. If I have an x minus 2, my answer is a +2. Right, so it's just going to be opposite sign if you have an x plus or minus a number. So that's just a little shortcut. Okay, now for the third one, I don't have an a equals 1. It's not plain Jane. First thing we got to do is look for that GCF. But there's nothing that 3, 8, and 4 all have in common. So there's no GCF I can take out, which means we're going to do some bottoms up. So I'm going to take my 3 and move it to make it part of the 4. So I now have x squared minus 8x plus 12 because we multiply. Okay, then I have a plain Jane, so I'm going to go to my parentheses. I want to multiply to a 12, but add to a -8. That's going to be a -6 and -2. And don't forget, I moved the 3, now I've got to take it back out. So I'm going to divide these guys by 3. 6 divided by 3 is 2. And then I can't simplify 2 over 3, so I leave it. And we got to do bottoms up one time. So this one becomes 3x minus 2. Right? Remember, this equals 0. So now, this one's easy. I can go straight to x equals 2. right? Because that's just the opposite sign. This one might not be able to, you might not see it right off the bat. So I'm going to come off to the side and do like we did before, set it equal to 0 and solve for x. So I add 2. So we get 3x equals 2, divide by 3, and we get x equals 2/3. Right? It's the same idea, but this one you might not be able to do in your head. So we got x equals 2 and x equals 2/3. One more. All right, we got 3x squared equals 9x. The first thing we got to do, set it equal to 0. So I'm going to leave the x squared over here. It's a lot easier if you have a positive x squared. So if this one's positive, if my bigger one's positive, I leave it so that I move everything else and have to deal with negatives. All right, these are not like terms, right? I have an x squared and x, so I can't combine them, so I'm just going to rewrite them. All right. Now, I can't solve by square roots because I have an x squared and an x term in there, so it's not like the ones up here. But I can still solve by factoring, right? Always, always, always look for a GCF first, right? So that means I'm going to start with my 3. 3 goes into itself, and 9. So I'm going to take out a 3, right? They both have variables. So I'm going to take my smaller variable, which is x to the first power. Then we divide. So I get 3 divided by 3 is 1. I had 2 x's. I take 1 out. That's x. Negative 9 divided by 3 is a negative 3. I had an x, but I took it out. So that's going to be just x minus 3. Okay, that is my completely factored form, which means I can set them equal to 0 and solve. So we have 3x equals 0, and then x minus 3 equals 0. Solve for x here, I divide by 3. 0 divided by anything is 0, right? This one, just like before, it's going to end up being the opposite sign. So we get x equals 0 and x equals 3. Okay, so solve by graphing, find your x-intercepts. Solve by square root, get the x squared by itself and then square root both sides, and then solve by factor, and then set every factor equal to 0 to figure out what x is.